class we have to discuss about the operations on the real numbers. Okay, so you already know what is the real numbers. Okay, real number includes all type of numbers, which means whole numbers, natural numbers, integers, rational numbers, as well as irrational numbers. Is it right? In other class you already done about the properties of rational numbers. Is it right? So the commutative property, associative property, and distribution law, etc. Okay, with respect to the addition, multiplication, subtraction, and division. But in the case of irrational numbers, first we have to see here. Irrational numbers are the non-terminating decimal expansion. Okay, and rational numbers are non-terminating repeating decimal expansion as well as terminating decimal expansion. Okay, but in the case of irrational numbers are addition and multiplication with rational numbers. Addition and multiplication with rational numbers. How we get? See here. Addition and multiplication with rational numbers. See, this is 2 plus root 3. 2 is a rational number and root 3 is an irrational number, or 2 into root 3, which means 2 root 3. Okay, 2 into root 3 gives 2 root 3. 2 is a rational number and root 3 is an irrational number. Okay, see here. So 2 plus root 3, it is a non-terminating, non-repeating decimal expansion, and it is also non-terminating, non-repeating decimal expansion, which means both are irrational numbers. Is it right? So irrational numbers, addition and multiplication with rational numbers always gives irrational number. Okay, it concludes it always gives a irrational numbers. But in the case of only irrational numbers, their sum or difference and quotient and product are always used as a rational numbers. How it is? See one example. Okay, one example. So I have to take one example here. So first we have to take some example. Root 6 plus minus root 6. Okay, the sum. Next, difference example. See here. So root 3 minus root 3. Next, cosine example. Root 17 divided by root 17. The next product is root 3 into root 3. Is that right? So sum of two irrational numbers gives, so plus root 6 and minus root 6 becomes 0. So 0 is a rational number. Is it right? Next, see here. It is also gives 0. Its difference gives 0. Next, the cosine. The cosine gives 1. Root 17 ones are root 17. Is it right? So quotient gives 1. Means 1 it is also a rational number. Next the product. Root 3 into root 3, 3. And 3 is also a rational number. Is it right? So therefore, the irrational numbers, the two irrational numbers, sum, difference, quotient, product are always not irrationals. Okay, it may be rational numbers also. Is it right? So on this concept, which concept? The operations on the real numbers. Okay, on the operations on the real numbers on this concept, we have to solve some examples. Okay, so that's why you have to understand easily. Okay, you have to solve some examples. See here, this is example. Check whether 7 root 5, 7 divided by root 5 and root 2 plus 21 and 5 minus 2 are irrational number or not. Okay. See, first we have to find the value of root 5, root 2 and 5. Okay. See, a root 5 value is 2.236 so on. Means the root 5 value is non-terminating decimal expansion. Non-terminating, non-recurring decimal expansion. Is it right? So root 2 value is also same. Means 1.4142 so on. Which means is non-terminating, non-recurring decimal expansion. And the value of 5 is also same, 3.1415. The 5 value is 22 by 7. Is it right? So the value of 22 by 7 is 3.1415. So on. This is also a non-repeating, non-terminating decimal expansion. Is it right? So now we have to multiply 7 root 5 is equal to 7 into 2.236 gives rise to 15.652, which means it is also non-terminating, non-recurring decimal expansion. So which means this is an irrational number. Is it right? Next, see here. 7 divided by root 5 is equal to 7 root 5 divided by 5. 7 root 5 divided by 5. Okay, how it comes? See here. 7 root 5 into root 5 into root 5. Which gives 7 root 5. 7 root 5, root 5 into root 5, 5. Is it right? So 7 root 5 divided by 5 it gives rise to 3.134 so on. 3.1304 so on. It is also non-terminating, non-recurring decimal expansion. So it is also an irrational number. Is it right? Next here, root 2 plus 21. So value of root 2 is 1.4142 so on. Is it right? So plus 21 gives rise to 22.4142 so on. Okay. So it is also a non-terminating, non-recurring decimal expansion, which means it is also an irrational numbers. Next, see here, pi minus 2 is 3.1415 minus 2 gives rise to 1.1415 so on. It is also a non-terminating, non-recurring decimal expansion, so that's why it is also an irrational number. So these 4 operations, okay, this is a multiplication operation, this is a division, this is a addition, and this is a subtraction. So all these 4 operations when the sum, difference, quotient and product, okay, product with doing the operation with any one natural numbers. Okay, square root with any one natural numbers. Is it right? See here. Square root with any one natural numbers. Any one natural, these are the natural numbers. 7, 21, 2 are the natural numbers. Okay, and root 5, root 2, 5 is also a square root. Okay, that's why the square root with any one natural numbers with all operations, which means addition, subtraction, division, multiplication, gives rise to always and irrational numbers. Is it right? Gives rise to always and irrational numbers. The irrational number means it is a non-terminating, non-recurring decimal expansion. Is it right? So we have to note down these answers and give concludes. Concludes means the all are irrational numbers. Okay, that the all are irrational numbers. So we shall start here, and I hope you understand this concept of operations on real number. In the upcoming class, we have to solve more examples on the concept of operation on the real numbers. Okay, thank you.